All right, so what is the #1 water-using device in a home or an apartment? And if you answered toilets, you got it right. Introducing Niagara Conservation, some of the top tier toilets on the market, affordable and lowest flowing around. Introducing the Stealth, 0.8 gallons per flush, single flush, or a new dual flush that goes down to 0.5. And new to the market this year in 2018, the Nano, 0.6 gallons per flush average, 0.8 on one end, 0.5 on the other. It's the lowest flowing toilet known to man, except for compost, of course. Check that out in the fall. Using vacuum-assisted technology and other innovations, Niagara toilets are not going to fail, and they use much less water than the conventional. Green Home Institute has glowing reviews from affordable housing renovation specialists who only spec these toilets because they're more durable than even conventional ones and start to reduce the growing burden of water costs, especially for those who need it the most. So you know if it works in these situations, it's going to work anywhere. The original Stealth now has a durable side handle, innovative and stylish, able to be fully compliant with ADA as well. And in bonus, you can check out the AM Conservation WaterSense certified 1.25 gallon per minute shower head and 0.5 gallon per minute faucet aerator. This can be renovated into an existing home or during new construction. You won't even notice a difference in any of these. Reduce water and reduce hot water as well. All right, well, welcome everybody to Reducing EMFs in Residential Construction, Part 5, Assessing and Mitigating Dirty Electricity. This course is approved for 1 hour in continuing ed, GBCI, AIBD, Certified Green Professional, BPI, non-whole house, and NARI Green, as well as AIA Health, Welfare, and Safety approved, and that may make it applicable for your local design or contractor's state-based license. Today I'll be your moderator, and my name is Brett Little, and I am the Executive Director here at the Green Home Institute. This session is a 5-part series that's been ongoing, reducing EMFs in renovation and new construction. If you missed the 1 through 4, don't worry. It doesn't have to necessarily be watched in order, but this is the 5th and final series of the intro and the main 4th and final type of EMF for dirty electricity as a part of the different EMFs. All right, so with that, I'm going to introduce our speaker today. Frank is a BBEC certified building biologist, EMRS electromagnetic radiation specialist with over 35 years expertise in electronics ranging from industrial, military, automobile, computer, audio recording, and home theater. Frank frequently lectures on EMFs and their biological impact on our health. And Frank was the former program director and instructor for the Institute of BAU Biology and Ecology, an organization that educates the general public and working professionals about how to create healthy, healing homes and workplaces. So with that, I will hand it off to Frank, and feel free to take it away.
Exposure to EMFs. Oh, maybe you didn't hear me at first. Thank you, Brett. Welcome to the webinar on reducing occupant exposure to EMFs in residential construction. This is Part 5, Understanding Dirty Electricity, also known as DE. Electricity was originally intended as a clean and safe source of power for homes and businesses through standard usage of steady electrical frequency of 60 oscillations per second, or 60 hertz. 50 to 60 years ago, it was a much cleaner source and had fewer complications with external devices. Devices were a lot smaller, as you can see. You know, we had large refrigerators and stoves, and then we started getting early microwaves in about the late 70s, early 80s. the thing is you have to understand how dirty electricity is created and distributed, so we understand how we're getting it into houses. Initially, electricity was generated as a DC or direct current source. This is the Pearl Street Power Station in New York City. In 1982, Thomas Edison opened this. The Pearl Street Station was one of the world's first central electric power plants and could power up to 5,000 lights. Back in 1982, basically electricity was just used for lighting, for lighting instead of gas lights. Pearl Street Station was the first direct current power system, but there were issues involved with that, and that it had huge losses over distance through the wiring. To alleviate the problem, AC alternating current was introduced, and it's used today. Electricity is produced by a power plant, and that's over on the, let's see, okay. Power plant here, all right, and it goes to a transformer which steps the voltage up to a very high voltage, 465,000 volts, for example. It'll run to a transmission line which will carry it over a great distance, up to thousands of miles. And then it'll come to a neighborhood transformer or to a substation that will reduce that voltage to a more usable level, not to the house yet. It still has to get to this. Right here is another transformer that's on the telephone pole that feeds your house. It's 220 volts, which is 120 on each side of the two phases of the electrical panel. This is a very simple way of approaching it, so you can, just get an idea on how it gets there. And the power plant can be hydroelectric, it could be nuclear, it can be coal-fired, it could be solar, it could be many different ways. In the early days, the first issues that came across were in the telecommunications industry. First the telegraph and then the telephone. Problem was noise or interference. Back then they didn't call it noise, they just called it interference. And this was created by sparks from the motors and machinery as we got more industrialized. So these motors would be in factories, machinery would be in factories, and there would be these noises generated through electrical wiring that would disrupt the communications, so you couldn't get a clear audio signal, you couldn't hear voices, or you couldn't send a transmission, it would be all garbled. So they came up with a term called electromagnetic interference. This is more of an industrial or commercial name for it, or EMI. It's also known as radio frequency interference because it's in the radio band here, and it goes into the AM radio band. And as we go higher and higher, we get up into the megahertz, which get into portable phones, cell phones, and then we get up into Wi-Fi and radar. The distribution is caused by an external source, which affects the electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. The disturbances may degrade the performance of the circuit and maybe even keep it from working. In the case of a data path, it can cause a computer to crash. As you can see, I'm sure many of us have seen these screens before. The large one here is the blue screen of death, we call it, for a Windows operating system. And then the old days, it used to be a sad Mac face, or the computer will have this little box here telling you that something's not right. There is both man-made and natural EMI. This is some natural EMI, or electromagnetic interference. Lightning is one of them. Tree branches hitting a power line is another one. Sunspots, solar flares. And these can also get into the cellular, the portable phone, and the radar frequencies, the higher frequencies besides the AM radio, and they'll come up as static or clicks or blips, and it could cause, again, communications to stop, devices not to work properly. EMI frequently affects AM radios. It also affects mobile phones, FM radios, televisions, smart devices. But it's not just broadcast. It can flow on the building wire and disrupt usage of plugged-in devices. Any person that's ever used a blender or a drill, for example, because of the motor, there's a motor in there, there are brushes that cause sparks. The wiring from it being plugged into the AC outlet will cause the wave or the interference wave to come back through the wiring and up to the television or through that. So right here, the source would be the drill right here coming through. It's coming through the components in the drill along the wiring. This would be the conduction. And into the victim, we call that the TV. And here it was showing the cordless phone more so than a cell phone, causing the older TV to have static. And this is what it looks like. Right here, you'll see the nice smooth sine wave. This is what we should be seeing. This is the dirty power that's superimposed, so you can see the difference. This is what it looks like on using a oscilloscope that's a PC. There's many ways of looking at this using different types of test equipment. Dirty electricity is a term used in modern times. This is a newer term rather than EMI to describe the AC electric power that is not smooth and harmonious to power up our electronic devices. It is the least understood and hardest to mitigate of the four types of EMFs, at least compared to the other types of EMFs that we encounter in the building biology profession. We're going to do a recap on that. Dirty electricity is least understood. The recap of the four types of EMF is AC magnetic fields from house wiring, AC electric fields from house wiring, radio frequencies from wireless devices. That includes portable phones, cell phones, Wi-Fi, radar systems, and then the dirty electricity. It's important to understand about DE, or dirty electricity. It can radiate not just from the device itself, but also from the wiring the device is connected to. As I mentioned earlier, blender or drill, these devices were some of the first devices that caused this kind of noise. And in the old television set, it was pretty frequent that if mom was running the mixer or running a blender, the television would be getting staticky. Same time, if you're listening to music on a radio, it would get all staticky, and actually this is what it would look like. Down here is all this noise. It's all jagged, and it's not nice, it's not clear, it's not clean, and it can be very annoying. These devices should have circuits inside them to prevent this, but not always the case. Due to cost factors and manufacturing concerns, sometimes these devices are compromised in their design. There are regulations to control these emissions, but they only have to satisfy the minimum requirements of the industry, and that's usually to prevent it from disturbing a radio or a TV nowadays, but there's no concern for biological response, which is what we're more concerned with now. Unfortunately, we can't turn devices off all the time. Client health concerns are always important. So if you have a client that has a CPAP machine, for example, and going back one slide to, we'll use the blender for example, and it's making this noise that you can see on the TV, or this hash that you can hear on the radio, in theory, it could affect the performance of the CPAP machine, or if they have an air filter that they need to keep the air clean because of allergies, it could affect the performance of that. So we have to be concerned about what we plug in to the outlet and what devices we're using, making sure it doesn't affect another device. As you can see, there are a lot of things out there in the world and in the home that can create interference, DE, dirty electricity, or EMI. You have your office here, you have your computer, you have your printer or fax machine, you have fluorescent lights, and then that's connected to the power grid. You have electric vehicles and electric streetcars, trams. We have radar units, we have entertainment devices, we have cell phone towers, microwaves, we have nature itself with static, lightning, we have police cars and ambulatory, we have machinery, and then in the house itself we have all these devices that produce EMI, DE, work tools, TVs, washing machine, radios, and you have your wireless devices, laptops, mobile phones. All these devices can produce unwanted interference, unwanted noise, EMI, DE, or dirty electricity. You're also getting it from your neighbors. So if this is your house on the right and your neighbor's over here, I'm going to go back one slide, and they have all this stuff going on in their house here. We have a connection between the wiring, feeding the house through the transformer, also to your house, and then we have, on many houses in the United States, we have copper pipes and iron water mains, so we have a connection here. And as you see, this can create a loop. So what that means is we have our neighbors down the street also connected to us. So you have the loops here, the loops here, the loops here, the loops here, coming through the water mains, coming through the electrical, and you have this big loop coming through each one. So we're all connected. And then you got the whole neighborhood itself. You have the office down the street, you have the hydroelectric plant, the industrial power plant, the rural neighborhood, the city, solar farms. All this is connected through the grid that is powering your house and powering everything else, and they all are producing their version of DE, dirty electricity. Windmill farms, solar farms from the inverters, industrial customers, power plants again. So it's all just a big loop of this dirty harmonic waves coming through the electrical grid. The exposure to dirty electricity has a potential to cause an exacerbation in existing health problems in some people. It is not something that can be smelled, touched, seen, or felt. Those people that are very sensitive can feel the effects of electric and magnetic fields. Dirty electricity does fall on that, but it's a non-steady state. It's a very jagged, disharmonious wave caused by the interference from these devices that are in the other houses, the electrical plants, the industrial plants, the electric cars, etc., that are being used daily. The health effects of dirty electricity were first identified as early as the 1950s, and it was in rural areas and farm areas where behavior and feeding patterns of animals were negatively affected by stray voltage caused by poor grounding and lack of utility infrastructure. Farmers were the first to deal with the effects of this problem. The animals would produce less milk or eggs or not grow as quickly or develop illnesses that required more advanced types of medicines to combat, which were not always effective. Finding the source and how it was getting in was usually the best way of fixing the problem. And again, as we saw before with the house, we have a loop here. We have the transformer being fed by the grid, the wiring coming to the barn or the milking barn, the ground wire going to the earth. So we have a ground wire over here from the transformer, and then we have a voltage running through the ground. And that'll change by the type of ground it is, by how wet the ground is, and where the animal's positioned. And I've seen this a lot in farms myself. I get calls when I go out to farms in rural Minnesota and rural Wisconsin and help them in trying to mitigate and help their livestock. So it's not just humans. Animals are actually more sensitive to this. So it's something to be aware of. If the animals are being disrupted, you know, being a farm animal, or if you have a cat or a dog in your house, you could be exposed to dirty electricity or electric and magnetic fields, and your animal could be telling you that, but you don't know it. The most common complaints: cognitive function, concentration, memory, behavioral, etc. Usually people that are having issues with DE or electric magnetic field issues or Wi-Fi issues, is the first thing typically is they can't sleep. That is the big one I hear about all the time. They get headaches, they feel depressed, they have discomfort, irritability, nausea, visual distortion, cardiovascular problems, respiratory problems, nervousness, agitation. And what do they end up doing? They end up going to a doctor, they end up prescribing medication, the medication is not working, they go back to the doctor again, they get different medications, and they just go through this vicious cycle of medications where the problem is they had a cell phone next to their bed while they're sleeping, or they had a clock radio next to their bed while they're trying to sleep. Many times, by just reducing or removing the exposure, the client gets better. In Sweden, sensitivity to dirty electricity is recognized as disability, affecting approximately 3% of the population. In Switzerland, the survey of doctors concluded that 5% of symptoms of patients could be traced to dirty electricity syndrome. In the old days, electronic equipment had large power supplies. Things got a lot smaller over the years, saved space, more energy efficient. The devices we use have circuit boards in them that don't operate on the 120 volts that is supplied by our wall outlet, so it needs a power supply. The 120 volts will come in here to this transformer and go to the circuit here and come out to the usable voltage off, in this particular case, these posts right here. And typical devices nowadays are running like on 5 volts to 19 volts. And the large power supply here is called a linear power supply. These were the cleanest. These converted the AC electricity, the 60 cycles, to the lower DC voltages of the 5. Typically it was 3 to 5 volts to 19 volts on an average, sometimes 24 volts. But they're big, they're bulky. This power supply is probably 19 inches long. So they came up with a method to shrink it down by chopping the electricity up, creating what is called a multiple voltage switch power supply or switch mode power supply. Laptop supplies are basically this also, but they'll be put in a small case to get the laptop smaller. And computer desk power supply is also same as this, but they'll put it in a case to sell as a component so that you could build a computer or swap it out to upgrade. Okay. Now, the problem is compact fluorescent light bulb also has to have a power supply because it does not operate on 120 cycles. 120 volts, I mean, excuse me. So it's an opposite. It actually operates on around 3,000 volts. So we have what's called a ballast. And it's a circuit to boost the electricity up to a higher voltage. And what it is the CFL was designed as an energy efficient alternative to the incandescent bulb to use as a lighting source. It converts approximately 25% of the input electrical signal, input electricity, to visible light. The standard incandescent light bulb is about 5% efficient. So we're only really gaining another 20%. It's still more efficient, but not a whole lot. But unlike the incandescent light bulb, it needs more complex startup and operating voltage. That's the ballast. The CFL, the problem is that the base is too small to house a linear transformer. So we have to make this little ballast switching circuit to raise the voltage up. The electrons come up and heat a filament, which what it does is it causes a charge to light up these mercury vapors or energize this mercury vapor that's inside. What that does, and the argon is more like a suspension gas, and that lights up the phosphorus coating, which gives you the bright light. The problem is there's a UV light also that comes from these energizing process, and there's phosphor in there that has to light it up. So you're getting a UV light that's not biologically good. It's not the best lighting. We've had people tell us that fluorescent lights can give them headaches. That's one of the reasons. But the problem with CFLs is they have mercury in them. And if you break a CFL, technically you should have a hazmat team clean it up. And if you break it on carpet, you're supposed to not vacuum it up. You're supposed to cut the carpet out and throw it away. So we're not a big fan of CFLs. Also, the byproducts. So if we're only using 25% of the energy that comes in through the base here to operate the circuit, to light the bulb, where's the other 75%? Well, as you can see here, the CFL is scorched or burned. So it creates a lot of heat. Never unscrew a CFL by the bulb itself. That is a great way of breaking them. Also, if you get cut from a CFL breaking, you could get mercury poisoning. So you really have to be careful with these things. Disposal should always be done at a recycling center, not thrown into your garbage. Okay. LED bulbs. LED bulbs require regulated DC current. These are basically miniature switch mode power supplies, just like the computer power supply I showed earlier. These are shrunk down power supplies to turn the AC electricity, which comes in through the base, through the wires here, to the circuit to light these LEDs. These are just strips of LEDs. They're like little circuits. You can see the solder connections. And they add more LEDs to get a brighter bulb. They do a very good job of lighting up and using the low voltage DC that comes from the conversion process of the switch mode power supply in the base. There are special LEDs that can be used to change the lighting characteristics, so like a dimmer. And some are more efficient than others. The problem is, again, this is a switch mode power supply, and it could be suspect to poor design issues or poor filtering, which could put more dirty electricity out. Dimmer switches is another device that has issues with how it operates, because how it works is it takes the AC electric signal right here and basically chops it up by turning it on and turning it off very rapidly, so you end up from a nice smooth sine wave to a more choppier wave to an even more choppier wave. So you're basically taking the electricity from a smooth, harmonious signal coming in to your switch here and turning it into this big chopped up wave, so that the light is actually flickering. So here we go. Clean electricity comes in, computer, router, CFL, comes out all choppy. This is different stages of the waveform and how it goes from a smooth sine wave to more lumpier as it gets broken up more and more till it becomes just a very distorted wave. CFLs, computer power supplies, the power supplies that run Wi-Fi routers, the LED power supply that runs an LED, the ballast in a CFL, all these cause these distortions in the harmonic waveform. Here's some more oscilloscope pictures so you can get a clearer idea. This is, we call this the switching noise. So as it's changing the transition from a positive wave to the negative wave, you get these distortions here and down here. You see the little spike. This is what it also can look like. Here is a more, this is the neutral, this is the return path from the AC. See how it's all distorted, nothing's clean about it at all. And this is what the switching looks like. You're basically chopping the signal up to many thousands times a second. Not only are you getting this on the wiring, but dirty electricity is, can radiate into the air in the immediate vicinity of the generating device, from the wiring of the building and from other devices that are plugged and affected circuit outlets. So what that means is, if you have something plugged in that's into your AC outlet and it's producing these harmonics, and you're running Romex plastic jacketed wire, that wiring now becomes an antenna and can radiate this field into the room. So you're not only just getting it from the device itself, now the wiring is now being an antenna, basically amplifying it and making it even larger. So it can be everywhere. So a device plugged on one end of the house could be radiating dirty electricity all the way to the other end of the house. And I have seen this many times. Solar panels is another, can be another problem. And the main issue is the inverter, this box right here. It's how it converts the solar energy to electricity so it's usable by the house and how we connect to the grid. They have a unique DE because it's associated to the conversion process, the panel itself, converting it to AC. There's a specialized mode of switch mode power supply that they use, and they can cause harmonics. Again, the conversion process is the problem. It doesn't mean we don't like solar panels. We do like solar panels. We need to measure what the inverter is putting out and seeing if it's traveling on the wiring to the lamp and being radiated out and through any of the electrical panel and any other sources that are actually out to any other devices in the house. So this is some of the common dirty electricity sources. We have our dimmer switches, which take the AC, chop it up, so we can brighten and dim the lights. Fluorescent lighting, which has a ballast in it to raise the voltage so that we can energize a gas and get the lighting out. Computers and laptops, they use multiple voltages inside to run the circuitry, the computer chips. Printers and scanners, solar panels, we have the inverters for that. Stereo equipment, they have low voltage wiring, but they also have power supplies for running the amplifiers and the different devices in there. The CD players are starting to go out of vogue there, so whatever other devices that they're plugged into. Video games, a lot of them are wireless now, but they still have to be energized, so they're plugged in. They'll have like a laptop power supply operating those. Televisions, now they're getting smaller and smaller, so they're outboarding the power supplies on those. When I mean smaller, thinner is what they're after. Washer and dryers have motors in them, and they have switching circuits in there for the timers. Kitchen appliances, simple blenders are now more complex. Microwave ovens have specialized power supplies for them. Of course, cordless phones. Voltage transients, these are things that put out huge spikes. You have your computers also that do that. Televisions, washers and dryers, electronic equipment, CFLs again, different types of electronics equipment, different types of power supplies and IT devices. All those can just put transients out. These are spikes rather than just dirty rising and falling voltages. More like, like I said, a spike. So something hard, something sharp, something very high amplitude to the signal. So now what do we do about it? Well, there's, okay, hang on a second. First, we have to figure out what's going on. So we need to measure the DE. There are simple methods and there are more complex methods. The important thing is to locate the source. We need to find out what's causing the DE or dirty electricity. And we have to verify what we found. Then we have to make a decision. Do we want to remove that device? Do we want to replace that device? Do we want to turn the device off? Or do we want to find something, replace it? And then we have to remeasure and verify the reduction. Simple methods of testing. We have the buzz stick, which is a little amplifier with a pickup. These are used so we can hear what's going on. An AM radio is actually a very good choice for this also. We want to use a battery-powered radio. It doesn't necessarily have to have a pull-up antenna, but it has to be an AM radio. And what we do with those is we can go and listen for the dirty electricity. And how we do that is if you suspect a device, you can turn on the buzz stick and listen for the sound, or the AM radio. And what we do is we turn that to an off station. We turn that to a, it might be the next slide here. Okay. AM radio testing. You need a handheld AM radio that's battery powered. You do not need to have an external extended antenna. You go to a quiet spot. I typically go outdoors where there's no electrical interference. And I set the radio up so that I'm between stations between 800 and 880. So it's just quiet static, and then turn the radio off. Then I go to my source, let's say a CFL, for example, or a dimmer switch. I turn that on, and then I turn the tester, which will be the AM radio, on. And I listen for a loud buzzing. If I hear a loud buzzing that the radio didn't have earlier, I just had the static, then I turn that device off or unplug it. If the noise goes away, the buzzing goes away, I've found my source. Then I can make a determine, can I unplug it? Can I change it out? Can I just use it when I need it and leave it off? So you have to find out what the source is. Just going around and randomly testing, you'll be chasing a lot of things that may or may not be causing the problem. A lot of times when we do this, we want to keep a device that's creating these noises, or this dirty electricity, off when we're sleeping, especially when we're sleeping. The buzz stick is similar. Like I said, it's a little amplifier. We used to get them at Radio Shack. If we go back here, if you go to EMFHelpCenter.com, he sells them. LessEMF.com also sells them. And they're quite useful for tracking down dirty electricity. Similar to the AM radio, you go and make sure that it's set up so that you're not picking up anything that you shouldn't be yet. You find the device that you think is causing the problem, and then turn the buzz stick on, and it will buzz. It'll make a loud buzzing sound. The device that you think is the problem, you go and you either turn it off, unplug it, or replace it, and typically your problem is solved there. These are simple testers made by Alpha Lab, which is the green wave, and by Stetzer, the Stetzerizer meter. Both companies make a filter that you can plug in to an outlet to where the dirty electricity can be coming from. So if you have, let's say, a lamp that's using a CFL, and you plug one of these filters in next to it, or some of these filters will actually have a plug-in on themselves that you can plug the lamp into to help filter it. There are mixed results with these types of filters. The meter is nice to have because you can have a visual representation of a simple visual representation of the dirty electricity. The mixed results is they don't completely filter everything out. They can take the dirty electricity signal, the harmonics, and shift them up or down depending on how the construction of the filter to an area that may not be as bothersome, or in some cases could be more bothersome to the client. So there's debates about that, whether to use them or not. I prefer not to use them myself. That doesn't mean don't use them. It's just, this is not about getting into branding of filters. It's about being aware of where the dirty electricity is coming from and what steps can we take to reduce it. The more sophisticated methods is you need to hire a consultant, because they're going to come in with an oscilloscope or spectrum analyzer. PC oscilloscope here is a oscilloscope or spectrum analyzer that uses a laptop. And a data logger is used as if there's a issue, let's say a spike, and your client is sleeping, and at 3 o'clock in the morning, they seem to get woken up every night at 3 o'clock in the morning. There could be something turning on either in the house or out on the grid that you can't find immediately, but you need to take data. So you have to take data log. You have to log data over a period of time. And this will do that, and it will give you a number, and the speaker is give you an audio representation, of what it picked up. And then you will be able to see what the time frame is in the data when you go back and look at the data and say, okay, at 3 o'clock, we got this spike at 7 volts or 70 volts or whatever it is. Then you can start narrowing down what device is causing it and where it's coming from. You need an experienced technician to operate these. This is not something the average homeowner or a consumer can do. It takes a lot of training and takes a lot of time to set these up. That's the disadvantage of going this method is if you got something really difficult you can't find, you're going to need a technician, certified building biologist, or an electrician that knows a little bit more than just wiring to trace this down. The advantage of the simple method, which going back to here, is the average consumer can at least get a rough idea on what's going on. Say, hey, I found this noise. I did a buzz stick test, or I did an AM radio test. I said, I've got noise here. I unplugged this, it went away. Do you have a suggestion? Or I unplugged it, it's still there. That's when you go and call the professional in to help make decisions. And then here again, you can buy these. They run anywhere from around, I think it's about $100 to $150, depending on which version. And you can plug them into your outlets. And the instructions will give you a reading of a range or a chart to tell you what range you should or should not be in. And again, they'll tell you to plug their filter in, and then the numbers go down. And, the important thing is the client is the one that has to be satisfied. Not that your meter says, I was at 100 and I went down to 32. You could do that. You could plug these types of meters in and put the filters in, and the numbers go down, but the client's still not satisfied. We don't stop there. That means you either didn't find it or you didn't reduce it enough. So the client always has the last word on whether these devices work or not. And I mentioned already about the pros and cons. Simple testing is quicker, but knowing the exact cause may not always be found. Many times simple testing can be used for a majority of the population. More sophisticated testing requires more expensive equipment, more setup time, but the results are more complete. Must be used for more difficult cases. Difficult cases require that extensive testing needed to use to pinpoint the exact cause. This may require multiple trips and other contractors brought in. That is the problem when you get into really complex situations. Data may need to be collected. The problem with that is you may have to leave expensive equipment at the client's house. Many technicians do not like doing that unless they have some sort of contract agreement. First thing we have to do, we have to locate the source. Number one, can it be removed? Number two, can it be switched off? Can it be relocated? Can it be shielded? Can it be replaced by something that's not so offensive? If not, what are the solutions? Shielding. With shielding, it's taking metal or a mesh screening and using it to block the electric waves. This will only work on electric field portion of dirty electricity. Dirty electricity has both electric fields and magnetic fields. Location. Locate the DE source as far away as possible. So let's say you have a clock radio, for example, next to the bed. And the client says they can't sleep. And the clock radio is plugged into the wall. You need to move the clock radio, unplug it, or replace it with something that's maybe battery powered. And I've seen that happen many times, and the client now can sleep again. Keep all electrical devices away from the bed area. This includes lamps, clock radios, cell phones, cordless phones, TVs, noise machines. The only exception would be CPAPs and like air purifiers, but they're plugged-in devices. They have power supplies. They can cause issues, so you have to be careful with that. Any medical device that a client needs, again, if it's plugged in, it's got a power supply, it could have dirty electricity. Filtering may help, like a green wave or a Stetzer filter, but again, the client is the final word on whether that works or not. Removal. Replace the DE source and devices as possible. CFLs can be replaced with higher efficiency incandescent bulbs or halogen light bulbs, or LED bulbs that have been tested for DE emissions. Simple test, AM radio or buzz stick. If it's making noise, it's got DE. If it's not making noise, it shouldn't have DE unless the client is very, very sensitive. Then you would need an oscilloscope or a spectrum analyzer to analyze the device, like a LED. Switch mode power supply for computer can be replaced with a linear transformer. That you would probably need a help of a technician or a building biologist with that. Desktops are a little more difficult because of the multiple voltages, but you can get replacement linear power supplies for laptop computers and such. Turn it off. Take the device, plug it into a shielded power strip to ensure the device is turned off. Many times devices, when you turn them off, are not turned off. They're actually in standby mode, like the new TVs, computers, wireless devices. You have to take the power away from the device completely to stop the transmissions. Unplug if it's not being used, or like I said, use a power circuit breaker, or resort to a circuit breaker shutoff. We mentioned that in one of the other sections. I believe it was about the electric fields, that we could turn the circuit breaker off, kill power to the entire room, so you know that there's nothing coming in. Filtering. You could use a whole house filter at the main electrical panel. This will usually clean up the DE coming in upstream, meaning that dirty electricity coming in from the power grid can be reduced. Depending on what's coming in, will determine how effective the filter is. Stetzer and green wave can be used, but with caution. Both types of filters are commonly used, and many times they have their merits, but wiring errors are a major concern. Before you start plugging in Stetzer filters or green wave filters or any kind of thing like that, you have to have the house checked for wiring errors. Neutral to neutral, neutral to ground shorts. The reason being is if you plug one of these filters in, you could make the situation far worse than if it wasn't plugged in. Always have the house wiring checked. Resort to, again, finding out what the source is. What can you do about it? If you can't get rid of the source, can you filter it? Try it. What does the client say? The plug-in filters can be more bothersome to clients than the DE itself. One of the things the filters create is a localized magnetic field, so you try not to plug these in next to the bed. Plug-in filters can shift the harmonics of the DE to a range that is more bothersome to the client. This is where testing with a spectrum analyzer is needed. That's more complex testing. In the end, as I said before, the client has the last word on what actually works for them. Sometimes a properly placed plug-in filter works, and that's all you need. Sometimes it does not, and you have to resort to other methods. In summary, many electrical devices cause DE, dirty electricity. DE can radiate not just from the device generating it, but also from the wiring it's connected to. Your neighbors connected to the grid and the water pipe system can transmit DE into your home. A note about the water pipe system, we covered that in, I believe it was in the magnetic field section, that the connection of water pipes to the main water to your neighbors can transmit magnetic fields called stray voltage or stray current. There is a procedure for that that's covered there that I believe we talked about that. That requires a professional to look into, but you can measure DE on water pipes if you have it. DE needs to be tested for to be found. Knowing what the source is and mitigating it would usually increase a client's well-being. When designing a home, considering the devices being installed in a home is an important step to reducing DE. Simple filtering may not always work. A whole house filter may be needed. This is to take care of what's coming in. Having a whole house filter does not necessarily mean that you will take care of any DE from devices plugged into the outlets. This is because the filter at the main electrical panel is taking care of what's coming in, but now you're already in the house. We call this downstream. Sometimes it can help a little bit, but many times it doesn't. Again, it has to be checked and tested for. Following building biology precautions can usually reduce this issue. DE can be introduced into a home anytime a new electronic device is brought in. So anytime you buy a new device, a new gaming device like an Xbox or PlayStation, I don't know what, whatever those are, they can bring DE in. Changing light bulbs, adding a dimmer, a different dimmer. Now there are some cleaner dimmers than others. Lutron and Crestron are two brand names of smart devices. They make smart home devices that have better circuits in their dimmers. Usually, if you follow if you're doing smart devices, if you follow the companies that are making smart or high-end audio gear, they typically have better filtering properties, so they typically have less dirty electricity being generated and radiated because they don't want their components to be suspect to the harmonics. That's it. I thank you.
Hey, great. Thanks, Frank. Well, we've definitely got some, I know we're at 1 o'clock, but we definitely got some time for questions. And while those questions are coming in, real quick, big thanks to all of our members, our board of directors, our sponsors, Build Equinox, CERV, GeoComfort, Niagara Conservation, Panasonic Ventilation, Certainteed, Formaldehyde Eating Drywall, and Shrinergy, solar microgrids, both portable and new microgrids for your house or building. For those of you listening here live, you'll be getting a survey that'll pop up or sent to you through email. Make sure to take that. Those of you watching on demand, make sure to take the 10-question quiz and get an 80% passing rate. Frank, one of the questions that came in, and I had this question, was, could you maybe help elaborate a little bit more on what this whole house filter is, what it costs, what it looks like, real briefly?
Whole house filter. There's several out there, depending on the brands. I didn't want to get into brands. It's a filter to put at the main electrical panel prior to the circuit breakers, or there'll be a set of breakers. The electrical grid, how it comes in on two 120-volt legs, so it's 220 across the panel. And you're going to need to filter it. You're going to need, some of them you just use one and it goes across both hots and the neutral. Sometimes you need two. There's different types out there. I didn't want to get into brand names. Orem, I think, has some, Orem Miller, Create Healthy Homes has listings there of some of these devices. What they do is they help to filter what's coming in from the grid, and some are more effective than others, and that's why I didn't want to get into branding names, because I have no affiliation with anybody. But
yeah, no, that's completely fine. We don't. I guess we were just looking at more of what they are, where you can find them. It sounds like on Orem's website, Create Healthy Homes, which we have listings to.
Yeah, hang on a second. Well, I looked this up quickly.
Yeah, plenty of questions. I think one of them, you probably answered this, but let's just reiterate for everybody. If people unplug things, that's one step, but do they also need to, I'm sorry, they turn them off at night, but do they actually need to also physically unplug them, or is there even a third tier beyond that?
Well, it depends. Let's say the new TVs, for example. You've got a new whatever brand, flat TV, OLED, etc. When you go and turn that off at night, typically with a remote, the TV is not completely off. It's in standby mode. A lot of devices nowadays are in standby mode. So to stop that, the easiest way, there's two ways to do it. One is you unplug the TV completely, or you put it on a power strip. Older TVs don't have the standby mode, and a lot of times you can tell because there'll be a light, an LED light, on the front panel or on the side that's still on. It may have changed color. I'm looking up the filter that we liked. Hold on, I'm going through my.
We can circle back to that. So, can you tell us a little bit more on the plug? So,
the Stetzer filter and the green wave.
Well, so there was a question, and I don't know the acronym, but maybe you can reiterate it for us. TVSS, and the question was, what is the price range for those?
TVSS.
Yeah, maybe we can have the attendee reiterate what that is. I guess I did not catch it. So. So the next question was, how powerful could the dirty electricity that rides on or is picked up on pipe and conduit nearby a smart meter transmitter be? I'm thinking this isn't as powerful as dirty electricity from an inline SMPS source, but maybe?
You want to say that again?
Yeah, how about we just put it this way. Are smart meters dirty electricity pickup typically more powerful than, I'm assuming what they're saying is, non-smart meter electrical panels?
The analog meters don't have dirty electricity. The smart meters have dirty electricity because of the circuitry inside, there's a couple of things they can do. One is they can transmit RF frequencies, and then there's conversion processes inside. So the question is, which is worse? Well, that really depends on the client. So you can't say that one is worse than the other because everybody responds differently. So in my opinion, plug-in devices generally are worse, but if the client is sensitive to the frequency ranges that are being broadcast by the smart meter or RF, it doesn't matter if it's a plug-in device or if it's a smart meter. They're more sensitive to one or the other. I have found that plug-in devices have a higher amplitude many times over a smart meter, but that's not always the case. So having one worse than the other, it's not really the case. It's getting rid of them. Getting rid of both is more of a concern.
Mm-hmm. Great, thanks. So we've got that acronym there. So the question was, what is the price range on those whole home filters or transient voltage surge suppressor? I guess is.
That's okay. Got it. Hang on a second. I'm looking right now. Between $250 and $500 up to over $2,500.
And what's the install cost?
What does electrician charge?
Okay, sure. Fair enough. It could be anything.
Right, because some of them are direct wire, some of them are not. So it really depends on how it has to be installed. And I'm trying to find a specific brand for you. And
oh no, we don't need to have that in this session. So
okay.
we'll just send that out as an email to everybody.
Okay.
But yeah, we don't need to cover that right now. So
there's
could you
one
confirm that truly clean 60 hertz won't make a buzz stick or AM radio buzz in close proximity?
What was the question?
So the question was, could you confirm that a truly clean 60 Hz won't make a buzz stick or AM radio buzz in close proximity?
You'll get a little bit noise, but you'll know the difference between clean and dirty. Dirty will sound really horrendous. A clean electrical signal on audio will just be 60 cycles. It'll be like a steady hum. Okay? Whereas dirty electricity will be really staticky, really nasty sounding, like, akin to somebody firing up a power saw. Like a radial saw, and that kind of jolting buzz that it makes when you turn a saw on. That's how I audio-wise. And I was working on a way to give you audio samples, but I couldn't get that the way I wanted it to work, so I had to go by visuals.
Oh yeah, maybe we can send something like that later. So I had this question too, taking a step back here, and let's say we're starting fresh on a new construction project, or maybe a gut rehab, where we really get to start over. What recommendations do you have, and going beyond that, are there, similar to how Energy Star certifies for improved energy, WaterSense certifies for improved water, are there certifications out there in some of these products that you're saying, there's cheap products being made and people, aren't putting the attention into these products that need to be to reduce the DE. So are there certifications out there that you folks are saying, look, they've went through our vetting process and we know that these should be safer for people during the new construction design stage?
Boy, that's more of an ORM question. Damon, are you online? You might be able to add to that.
Yeah, I'm here. Can you hear me?
Yes.
Yeah, I'm not familiar with any particular certification dynamics because a lot of the ones that are more Energy Star energy efficient is sometimes those are the ones that are dirtier with the switching mode power supplies and stuff.
Right.
But Yeah, I mean, I agree with you about the audio, the companies that are making more high-end audio and stuff. As far as a new construction, I would consider really mapping out how you're going to set up the electrical system, because there is ways to, for instance, with pumps and motors and all the system equipment that can potentially make dirty electricity, to isolate those components like into a sub-panel. And there are types of filtering that can block that stuff from getting into the rest of the system. So that's one consideration, is to work with somebody who can help design that based on what components you're going to be using or wanting to be using.
We have, as building biologists in general, we tend to talk amongst each others, and how the information gets passed around is we talk about what works, and we also talk about what doesn't work. So we're trying to build our own database up, and we don't have it yet, but we're working on a database of devices that we have determined that are more effective at reducing exposure but still being efficient. Because we also believe in efficiency also, but we're more concerned with biological response. And the problem is devices and procedures and everything comes out faster than we can, we could stay on top of it. So there's always something new coming out. The best way, obviously, would be if we had lobbying to make our, the powers that be more proactive than being reactive in cleaning this stuff up. So for a designer, finding devices that are cleaner, it's probably going to be tough, but talking to seasoned building biologists, asking what have they found that works, and taking some of those suggestions, and also having, finding things and getting them tested. Unfortunately, it costs money. It costs time and money to do this. But we have done it, and it can be done. And being proactive rather than reactive. Because once you put something in that is problemsome, you'll find that it's a lot difficult to get rid of it or replace it. So if you can think ahead of time. Some of the stuff that you're asking also was, we approached basics of it in the other lectures also, on the electric field setup and magnetic field setup, trying to reduce that. If you take those protocols into consideration, meaning setting up a new home for reduced electric field and reduced magnetic field and reduced RF exposure, a lot of times you'll take care of the dirty electricity part too, because you're already being proactive in setting up the house that way. Shielding of wires will help reduce some of the dirty electricity itself, for example, using metal clad or conduit. Running the wires in certain ways so that they're more placed away from the occupant, like where they're sleeping. All that will help. Will it get it all out? Not necessarily, because dirty electricity has an electric field component, has a magnetic field component. Making sure that we're concerned with the sleeping environment a lot of times, because that's where people rest, relax, and rejuvenate, where they come back to their natural self. Not charging your cell phone overnight is a perfect example. Or leaving it charged all the time, sitting there on the, next to your bed. Things like that will help reduce it. And again, even though you may have designed a very clean house or a clean commercial building, when the client moves in and they start plugging things in, things are going to change. So the environment can constantly change.
Yeah. Well, thank you. And, for everybody, we, in our Green Star program, certification program, we do have optional credits, a whole section on reducing EMF. And we're actually working with several of the building biologist team to upgrade that to sort of the 2018 version. I think it was made more than 10 years ago, and it's still ahead of its time. But we are upgrading it, and it will have recommendations and credits for those of you designing or remodeling to make improvements. So anyway, we gotta wrap up here, but I do want to get one question that I thought was pretty interesting answered, and then after you answer that, Frank, maybe you can just close out by telling us where we can get more information. And it seems to be a lot of people asking about where they can find out about these building biologists, so you can close out letting them know about that as well. But the last question, I think, was, you had mentioned that sort of this connectivity within cities or urban areas of stuff traveling through the power lines and through the water pipes.
Mm-hmm.
So the question is, what is the density where that becomes an issue or a non-issue?
I'll give you an example. I was working on a farm, actually, out in rural Minnesota about 5 years ago. And the client was, he was a farmer, and he was very sensitive to electric and magnetic fields. And at the time, we didn't really have an effective, whole house filter yet that we liked. So it was just him with a grid feed to his telephone pole with his transformer on there, the little, the CAN transformer, and his neighbor. His neighbor had a welding shop. And he said that he could feel the welding shop through the power lines in his house. And we ended up coming up with a filtering system similar to a plug-in filtering system at the electrical panel. We actually had to create something for him. But we're talking 2 houses. That was it. That's all you need is your neighbor having something in there that is bothersome, that's generating harmonics through the wiring coming through your shared transformer onto your power line, and you're picking it up. So the answer to the question is all you need is one other house or one device plugged in, and it could start. It really depends on how sensitive the client is. So density is not the issue. It's what is connected to the grid, or what's connected to the house and how we're connected to the grid. A lot of this can be cleaned up if the neighbor's house was filtered, for example, and your house was filtered. Sure, a large amount of it would have been taken care of at the electrical panel. Okay, and then you want to know where to find building biologists. So, okay, I got that for you.
Net, and there's a Find the Expert tab at the top.
Right, it's the second tab over, and there'll be a list of certified consultants, which would be building biologists. There'll be another click on for architects and builders. There's only a few there, but these are a lot of these people that are listed are instructors for the Institute, or have been instructors for the Institute. And
all right. Well, hey everybody, we actually need to wrap up here today. There were several more questions, Frank, but I'm going to go ahead and send them over to you, and we can kick them out to the group, either between you, Orm, and Damon. And for the rest of everybody else who may just want to contact you directly, where is a good place to do that?
It's up here, Frank DiCristina at GratefulDowsing.com, GratefulDowsing.com, or www.gratefulDowsing.com, or www.environmentalheating.com. healingservices.com. They'll take you to my Grateful Dowsing website. As I do more than just electric and magnetic field exposure.
Great. Well, thank you all for joining us. Thanks to you, Frank, for taking time. Thanks, Damon and Orem. We're going to be doing a wrap-up, closeout session to answer all of your questions here in the coming months, so please join us for that. But take care, everybody, and have a great rest of the week.
Thank you.
Thanks.